The discovery of 3I/Atlas in early July sparked immense curiosity among astronomers worldwide, as it was quickly recognized as an object unlike the familiar comets and asteroids that routinely pass through our solar system. Once its trajectory was confirmed, researchers realized it was traveling on a hyperbolic path, meaning it originated outside our solar system, making it only the third known interstellar visitor after Oumuamua and Comet 2I/Borisov. This rare classification immediately made it the focus of intense scientific scrutiny. As it approached the inner solar system, 3I/Atlas began exhibiting behaviors that continue to puzzle and fascinate experts. Last week, the comet reached its perihelion, its closest point to the Sun, and instead of following predictable patterns of gradual brightening, it unexpectedly intensified in brightness at a much sharper rate than models predicted. Even more intriguingly, the object began to appear distinctly bluer, an unusual characteristic for a comet undergoing solar heating. Typically, when comets near the Sun, sublimating ice releases dust that scatters sunlight in a way that reddens the overall coloration, not shifts it toward blue. This observation alone set off a series of questions, but it was soon followed by even stranger findings. NASA's Jet Propulsion Laboratory navigation engineer Davide Farnokia recently filed a report describing evidence that 3I/Atlas is experiencing non-gravitational acceleration, meaning it is speeding up in a way that cannot be explained by the Sun's gravity alone. This kind of acceleration can sometimes be observed in comets when they release jets of vapor or dust in specific directions, creating a recoil effect similar to a miniature thruster. While the phrase might evoke images of an alien spacecraft firing its engines, the more widely accepted interpretation remains that natural processes are at work. Harvard astronomer Avi Loeb, a well-known figure in astrophysics, and no stranger to headline-making theories, offered a detailed explanation on his blog. He suggested the object is likely losing a substantial amount of mass, perhaps up to a tenth within the span of a month. As sublimation intensifies due to solar heating, the object expels gas and dust at an accelerating pace, and this material streams out in a long plume behind it. The force of this material ejecting acts like a tiny rocket engine, pushing the comet slightly off its expected gravitational path. Loeb emphasized that this mechanism is standard physics for volatile rich bodies, even if the scale seen in 3I/Atlas appears unusually large. Further observational data offered additional clues. During an interview with NBC News, Loeb referenced measurements gathered by the Atacama Large Millimeter/Submillimeter Array, ALMA, in northern Chile. ALMA detected a deviation of roughly 4 arcseconds in right ascension from the trajectory astronomers had predicted for 3I/Atlas based solely on gravitational influences. This might sound minor to the general public, but for astrophysicists, such a difference is statistically significant and highly meaningful. According to Loeb's calculations, the degree of deviation observed corresponds to a mass loss event equal to roughly 1/6 of the object's total mass, an astonishing fraction for any celestial body in such a short period. If this rate of evaporation continues, astronomers expect a massive plume of dust and gas to accompany the comet when it reemerges from behind the Sun in November and December of 2025. Loeb predicts that observers may witness a surrounding cloud containing more than 5 billion tons of expelled material, making it potentially visible even with modest telescopes. This mass loss could also explain the object's rapid brightening. As more dust is ejected into space, sunlight reflects off the increasing surface area of particles, causing the object to appear brighter than it otherwise would. However, even with these natural explanations, some mysteries persist, particularly regarding the comet's shift to a blue coloration. Loeb stated that dust scattering should typically make a comet appear redder, not bluer than the Sun, prompting him to explore more speculative ideas while acknowledging their uncertainty. He noted that if the blue light cannot be accounted for by natural processes, it might theoretically indicate a source of artificial illumination or heat, such as an internal engine emitting high-energy light. Although this interpretation leans toward science fiction, Loeb has long encouraged the scientific community to remain open to unconventional possibilities when anomalies arise. He argued that dismissing alternative hypotheses without thorough investigation could hinder scientific progress. Nevertheless, Loeb also acknowledged that natural explanations remain more likely, particularly the presence of ionized carbon monoxide gas. When CO is irradiated by solar ultraviolet light, it can emit a bluish glow, which might explain 3I/Atlas's coloration without invoking artificial mechanisms. This possibility remains consistent with its classification as a comet, especially one originating from a different star system, where chemical compositions may vary from the comets familiar to astronomers in our own solar system. Despite the observed acceleration, Loeb assured the public and scientific community that the forces acting on the object are not strong enough to significantly alter its path toward any planets. It will not come dangerously close to Earth, nor is it expected to intersect with major celestial bodies in a disruptive way. However, Loeb's efforts to study 3I/Atlas more comprehensively have hit unexpected obstacles. Due to a government shutdown, communication with NASA officials has been strained, and Loeb reported that he has not received updates regarding potential observations made by NASA's Mars Reconnaissance Orbiter during the object's flyby of Mars last month. Such data could provide invaluable information about the comet's composition, mass, and changes over time. Loeb expressed frustration during his NBC interview, stating that withholding scientific information during a crucial observation period is detrimental to ongoing research. He emphasized that astronomers around the world are planning future observation campaigns based on currently available data, and delays in data sharing risk disrupting carefully coordinated efforts. He stressed that transparency is essential for maximizing scientific understanding, especially when dealing with such a rare and fleeting interstellar object. Still, despite these setbacks, Loeb insisted that researchers would continue pushing for answers, striving to gather as much information as possible about 3I/Atlas before it exits the solar system forever. In the broader context of interstellar visitors, 3I/Atlas adds another layer of complexity to astronomers' growing understanding of objects originating beyond our solar system. Each visitor provides a brief but invaluable glimpse into the material composition and physical behaviors of celestial bodies formed around distant stars, offering clues about how planetary systems across the galaxy might evolve. Unlike 2I/Borisov, which behaved much like a typical comet, and Oumuamua, whose peculiar shape and acceleration continue to fuel debate, 3I/Atlas appears to combine characteristics of both, displaying natural cometary activity while also exhibiting anomalies that challenge existing models. Its dramatic mass loss, rapid brightening, unusual coloration, and measurable non-gravitational acceleration all contribute to its scientific significance. As 3I/Atlas continues its journey, disappearing behind the Sun before its expected reappearance in late 2025, astronomers will monitor it closely, eager to see whether current patterns continue or new surprises emerge. Whether it ultimately proves to be a naturally volatile comet with unusual properties or a more exotic interstellar oddity, its behavior provides a compelling reminder of the vast diversity of objects that populate our galaxy. Each new observation deepens our appreciation for how little we truly understand about the universe beyond our solar system. For now, 3I/Atlas remains a captivating mystery, one that blends established science with tantalizing questions, pushing researchers to examine both conventional explanations and more imaginative possibilities as they seek to unravel its secrets before it slips back into the interstellar void.